Hi everyone, this is Mrs. Snowbeck. We are going to be starting Unit 4. And Unit 4 will be studying polygons, and specifically we're going to dig really deep into quadrilaterals. To start out though, Unit 4 Lesson 1 focuses on polygons in general. So remember, polygons are closed figures. Their sides are made out of segments. You cannot have a curve in a polygon. And each side intersects exactly two other sides, and where the sides meet, those endpoints are called vertices. So for example, on this arrow, this is a vertex, 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 and when you have more than one vertex, they're called vertices. So this arrow would have 1, 2, 3, 4, 5, 6, 7 vertices. These other two shapes are also polygons. This circle, not a polygon. This heart, not a polygon. This, not a polygon, because it's not a closed figure. So you have to have straight sides, it has to be closed. This is not a polygon because it has to intersect exactly at the endpoints of the other segments. All right, I want you to pause the video and see how many names of polygons you can remember. Like, what's a three-sided polygon, four-sided polygon? So go ahead and pause the video, and when you're done, unpause to check your answers. So a three-sided polygon is a triangle. A four-sided is a quadrilateral. A lot of people put square there or rectangle, but that's only one type of a quadrilateral. So a quadrilateral includes all four-sided polygons. Then we have pentagon. I think of the Pentagon in Washington, D.C. It's a building that actually looks like a pentagon, and then inside there's a courtyard in the shape of a pentagon as well. So pentagons have 5 sides. Then 6 sides is hexagon. 7 is one a lot of people don't know yet, but you will. You'll have to know this for the next quiz. 7 is heptagon. Heptagon. Some people think it's septagon because sometimes sept is used for 7, but heptagon is the name of the polygon. 8 is a really common one. It's octagon. 9 is nonagon. Not ninagon, but non, N-O-N. 10 is a popular one. It's decagon. The way that I remember that one is a decade has 10 years and a decagon has 10 sides. 12 is dodecagon. And then we get to 13, and 13 and beyond, what we're going to do is we're just going to call it a 13gon, and a 14gon, and a 15gon. And you might have noticed we skipped 11. 11 you can call an 11gon. I believe if you Google it, you can find names for them. I think 11 is hendecagon, but most mathematicians after a certain point will just call them their number -gon. So 3 through 10 and 12, I want you to use the actual name. And then 11, 13, and beyond, you can just use the number -gon. So whatever number n is, you call it that number gon. So n-gon. Another thing that you should know about polygons is you can have convex polygons and concave polygons. And the way that I remember is concave polygons cave in. Some people call concave polygons non-convex polygons, and that's fine. That's another name for them. But I think if you think of concave, you'll think of caving in. Technically, the mathematical definition says if you pick any 2 points in a polygon, like let's say I pick this point and this point, and you connect it, no matter where you pick your 2 points, it will always stay inside the polygon if it's a convex polygon. But if you have a concave polygon, sometimes you can pick 2 points, and when you connect it, it goes outside of the shape. That's an indication that it's a concave polygon. And so you can see some more examples of those below. So think of these polygons. The first one here has 3 sides. known as a triangle, and the sum of the interior angles is 180 degrees. In other words, it's one triangle times 180, and that means the angles inside of the triangle, this angle, and this angle, will add up to 180 degrees. The next shape has 4 sides, so this is a quadrilateral. And if you wanted to figure out the sum of the interior angles, what all of the angles inside of it add up to, what you can think of is dividing it into triangles. Now, in a quadrilateral, you're going to get 2 triangles. Each triangle is 180 degrees. That is 360 degrees for the sum of the interior angles of the quadrilateral. In other words, if I add all of these angles together, they will add up to 360 degrees. The next shape that we have has 5 sides, known as a pentagon. And if you think about breaking that up into triangles, if you start from one vertex, you can break it up into 3 non-overlapping triangles. Each of the triangles is 180 degrees, and 3 times 180 is 540 degrees. So the sum of all the angles inside of a pentagon will add up to 540. So if you picture adding all of these angles up, they would add up to 540 degrees. Next, we have 6 sides. This is known as a hexagon. If you start at one vertex and you divide it up into non-overlapping triangles, you can get 4 triangles. 1, 2, 3, 4. 4 triangles. Each triangle is 180 degrees. 4 times 180 is 720 degrees inside of a hexagon. So think of an n-gon. How many sides does an n-gon have? Well, n is however many sides it has. It could be 10, it could be 200, we don't know. So n is the number of sides. So can you think of a way that we could figure out the sum of the angles inside of an n-gon? Well, remember when we had 3 sides, it was 1 triangle. When we had 4 sides, it was 2 triangles. 5 sides, it was 3 triangles. Wasn't it always 2 less triangles than the number of sides? So here's the formula. N minus 2 times 180. However many sides you have, take away 2 from that, and then multiply times 180 because that's how many triangles would fit inside the shape. Let's go to the next column. Let's find the measure of a regular interior angle. So we have a regular triangle here. And what that means, if you see the word regular, is all sides are congruent, all angles are congruent. And so all of the angles inside of this triangle must be the same size. Well, we already know this. If you take 180 and divide it evenly into 3 parts, you're going to get 60 degrees is the size of one interior angle of a regular triangle or equiangular triangle. What if you have a quadrilateral that's regular? Well, that means all the sides are equal and all the angles are equal. So take 360 degrees, which is what fills up the quadrilateral, divide it evenly into 4 parts, and you get 90 degrees for each corner in a regular quadrilateral. What if you had a pentagon that was regular? That means all of these angles would be the same size. So you take your 540 and divide it evenly into 5 angles. That ends up being 108 degrees. Let's say you have a hexagon, a regular hexagon, so all 6 angles are the same size. So you have to take 720 and divide it evenly into 6 parts, and you wind up with 120 degrees for each of those angles individually. So what about for an n-gon? Well, we took the sum of our angles, the sum of the interior angles, which we can get by doing n minus 2 times 180. And then we divided it by the number of sides. And so that's going to be your formula for finding the size of one interior angle in a regular polygon. Now, last but not least, this column at the far right, let's find the measure of a regular exterior angle. So again, regular means this is an equilateral triangle and also equiangular. And we want to know, how big is this exterior angle? How big is this exterior angle? How big is this one? Well, if you think about an equilateral triangle, each of those interior angles are 60 degrees. So this little angle right in here is 60 degrees. Together, these must add up to 180. And 180 minus 60 is 120. And this is 120, and this is 120. And what happens is those three angles add up to 360. Every single polygon, the exterior angles add up to 360. The interior angles add up to all different things depending on the number of sides, but the exteriors will always add up to 360. So to find the measure of one exterior angle, what you're really going to do is 360 divided by the number of sides, and you'll get the size of one of the exterior angles. So in a triangle, it's 120. So let's test our theory. If we take 360 and divide by 4, we get 90 degrees for the size of an exterior angle. Does that make sense? If I extend this, would this exterior angle be 90? Would this exterior be 90? Would this? Oh, they would, wouldn't they? And that adds up to 360. So for the pentagon, we're going to take 360 divided by 5. We get 72 degrees. That means the exterior angle, I'll try to draw one in here. Like if I draw one up here, this angle right here is going to be 72 degrees outside of the pentagon. Next, let's do the hexagon. So 360 divided by 6 is 60. And so if I extend one of these sides like this angle out here would be 60 degrees. So how do we get it for a n-gon? Well, we just take 360 and divide by n. And that would give you the size of one exterior angle. So that was a lot of information on that last slide. Let's put it to use. Number 1, what is the sum of the interior angles of a heptagon? Now remember, sum means what is the total amount of all the angles added up inside of a heptagon. Well, a heptagon has 7 sides. So remember, it's 2 less than that. So if we do 7 minus 2, that's the number of triangles that can fit inside, and then multiply by 180. So really it's 5 times 180, and 5 times 180 is 900 degrees. So if I have a heptagon, all the angles inside of it will add up to 900. What if I have an 18-gon? Well, I do 18 minus 2 times 180. So that's really 16 times 180, which is 2,880 degrees. That's the total number of degrees, the sum of the interior angles of an 18-gon. So count the number of sides here. 1, 2, 3, 4. There's 4 sides. This is a quadrilateral. And it wants us to find x, the measure of angle A, and the measure of angle B. Well, quadrilaterals, the interior angles add up to something. They should add up to 360. But let's say you forgot that. One thing you could do is you could do 4 minus 2 times 180 because it has 4 sides. So 4 minus 2 is 2. 2 times 180 is 360. Which means if I add all 4 of those angles together, I should get 360. So let's do that. The 3x plus the x plus the 90 plus the other 90 all together should equal 360. So that's 4x plus 180 equals 360. subtract 180. 4x equals 180. Divide by 4, x equals 45. Haha. We have one of our answers. I guess it's not degrees, it's just the value of x. But if we wanted to find the measure of angle A, I'm going to have to take that 45 and I'm going to have to plug it in up there. So it's going to be 3 times 45, which is 135 degrees for the measure of angle A. And for the measure of angle B, well, that's got one of those little 90-degree corners in there, so it's just 90 degrees. How many sides does this polygon have? 1, 2, 3, 4, 5. So this is a pentagon. To figure out what the angles should add up to, we do 5 minus 2 times 180 because it has 5 sides. That's 3 times 180, which is 540 degrees. So all of the corners or angles inside of there together should add up to 540. So you're going to make a big equation. So take a notice here. We have 3x, 2x, 2x, 3x. If you add up all of those x's, 3 plus 2 plus 2 plus 3, I believe that's 10 x's. Then look at your numbers. You've got 14, 142, and 14. If you add up all of those numbers, I believe you get 170. All of that added together is 540 degrees. Minus your 170. So 540 minus 170 is 370. Divide by 10, x equals 37. And if you look at the question, it just says find x, so we are done. We don't have to plug it back in. Sometimes it'll say find the measure of angle L or something like that, and you might have to plug your answer back in, but not this time. If the measure of an interior angle of a regular polygon is 135 degrees, find the number of sides this polygon has. So imagine this. We have some kind of a polygon. We don't know how many sides it has, but each of its angles is 135 degrees. And I know that because it says it's regular, so all the angles have to be the same. And we have to figure out how many sides does this thing have. Well, there's a couple different ways to do it. There's an equation way, which I think is kind of a long, complicated way. And then there's the shortcut way, which is the way I like to do it. So imagine straightening this out and having a linear pair. If you do 180 minus 135, you wind up with 45. That means this exterior angle out here would be 45 degrees. So remember, every single polygon, no matter how many sides it has, the exterior angles add up to 360. So we need to figure out how many 45s will it take to get to 360. So 360 divided by 45 is 8, which means it's going to take 8 45s, or in other words, it's going to have 8 sides, and it's going to be an octagon. Number 5. So look at all of these angles that are marked. They're not interior angles. They're not inside of the shape. They're actually outside of the shape. And so since they're exterior angles, it doesn't even matter how many sides this polygon has. They're going to add up to 360 no matter what. So I'm going to take all the x's. 5x, 4x, 5x, 4x, 6x, 2x, 5x. And I'm going to figure out how many x's is that. Well, I got 31x. Now look at the constants, or the numbers here. We have negative 12, 3, negative 5, negative 6, positive 5, positive 3. Combine all of those. When I did it, I got negative 12. And remember, these are exterior angles, so when I combine all of that stuff, it's going to add up to 360. No matter what shape, the exteriors add up to 360. So add 12. You get 31x equals 372. Divide by 31. And if you type that in your calculator, you should get 12. Have we answered the question? Yep, it says find x, we found x. Number 6, what is the measure of an exterior angle of a decagon? Okay, a couple of things. Decagon, how many sides is that? Think decade, decagon, that's 10 sides. Exterior angles. Exteriors always add up to 360. So what's the measure of an exterior angle of a decagon? Well, if they all add up to 360 and there's 10 of them, just divide by 10. 36 degrees is the size of each exterior angle on a decagon, a regular decagon. Well, that's it. It's time to try Unit 4, Practice 1. If you have questions, please send me a Schoology message. Good luck.